Hey guys, today we're going to talk about classifying the elements. It's the second part of our unit about the periodic table. So here today we're just going to talk about describing some information that's on the periodic table. We're going to classify the elements based on electron configuration, and then I'm just going to let you know about representative elements and transition metals. It's important to distinguish between the two. All right, let's get started. So here we see some information that's given on the periodic table for each element. The number at the top, as we see here, 11 for sodium, is the atomic number, and that represents the number of protons. Extremely important. We learned that before. Then we have the symbol. The symbol for sodium is Na. Then we have the name, sodium, and then finally we have the atomic mass. And remember, the atomic mass is a weighted average of all the isotopes of an element. This is the basic information that all periodic tables will give. Elements have different classifications, and here's a list of the different ones that we're going to talk about. Let me just show you where all of these classifications are on a periodic table. Okay, so the alkali metals are all the elements in group 1, starting from lithium all the ways on down to francium. These guys right here, these are your alkali metals. Okay, let's jump to the next one, the alkaline earth metals. All those guys can be found in group 2. These right here are the alkaline earth metals. Okay, let's take a look at where the transition metals are. These are really important. They're all the D block elements. I'm going to circle them right in here. There we go. We call these the transition metals. Okay, let's take a look at the metalloids. The metalloids we looked at before. And it's, remember the staircase over here, starting with boron, going diagonally. All right, there's 7 of them. And don't forget these 2 down here. These are your metalloids. And as we talked about before, they separate your nonmetals, which are up in this area, from the metals, which are everything else on the periodic table. What we're talking about today, these little other various classifications, as we can see here, that's on your periodic table, it's just another way to classify elements. Okay, another class of elements are the halogens. The halogens are all the elements of group 17. There you go, halogens. And the Nobel gases are everything in group 18. These are inert gases. They're unreactive. There you go, Nobel gases. Down at the bottom here, we have the lanthanides, which are everything here. These are our 4F block elements. Remember the 4Fs. And then the actinides are right below it, the 5Fs. Okay, so one of the reasons elements are classified the way they are is because of their electron configurations in the various groups. Remember, the groups are the columns that run up and down on the periodic table vertically. There are 4 types of basic ones that we'll talk about: the noble gases, representative elements, transition metals, and the intertransition metals. The noble gases we've already talked about. Those are all the elements in group 18. There they are. So notice something about the group 18 elements. If you look at level 2 for neon, look at the electron configuration, 2s2, 2p6. Add up all the electrons in the highest level, level 2. 6 plus 2 is 8. There's 8 outer electrons. This is something all the Nobel gases share. Take a look at argon. What's the highest level there? Level 3. 3s2, 3p6. Add up the electrons. 2 plus 6 is 8. Again, 8 valence electrons in the outer level. Look at krypton. The highest level is 4. 4s2, 4p6, add up to 2 to the 6, that's 8 again. They all share 8 valence electrons. Helium is also in this group. It's also a noble gas, but it only has one shell, so it can't possibly fit 8. There's not enough room because it's so small. Helium only has 2 valence electrons. Groups 1, 2, 13, 14, 15, 16, and 17 are called representative elements. Representative. They kind of have a special name because it's a little trick. We can look at the group numbers 1, 2, 13, 14, 15, 16, 17, and that tells us the valence electrons. So everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. 3 valence electrons, not 13, 3. Just knock off the teen. There's no teens. Group 14 has 4 valence electrons, 15 has 5, 16 has 6, 17 has 7. Notice how the D block elements are not included. The transition metals, they don't play this game. You can't tell their valence electrons just by what group they're in. There's a different way to tell that, which we'll learn about in the future. But for now, the group numbers represent the valence electrons of the representative elements. Notice the electron configurations of some of these group 1 elements. Lithium, highest level is 2s1, 1 valence electron. Sodium, 3s1, 1 valence electron. Potassium, 4s1, 1 valence electron. There you go. That's the key. The group number tells you how many outer electrons. Let's look at elements in group 14. Carbon consists of 2s2, 2p6 in its highest level. 2 plus 2 is 4. It's in group 14, 4 valence electrons. Look at silicon right underneath it. 3s2, 3p2. 2 plus 2 is 4. 4 valence electrons. See how this works? The periodic table is amazing. Germanium, highest level is 4, 4s2, 4p2. 2 plus 2 is 4, 4 valence electrons. This works for all the representative elements. And again, contains that many outer electrons. Here are the transition metals. You can't really tell how many outer electrons they have just by looking at their group number. The inner transition, these are the lanthanides and the actinides. You can't tell how many valence electrons they have just by looking at the group number. Can't do that. That only works for the representative elements. But just know that the outer level S and nearby F orbitals contain electrons. Okay, so just to recap, let's take a look at this periodic table again. Groups 1, 2, 13, 14, 15, 16, 17 are called representative elements. These are called your transition metals. Okay, and finally, remember that the group number represents the valence electrons on the representative elements. Over here, group 1 has 1 valence electron, group 2 has 2 valence electrons, group 13 has 3 valence electrons, 14 has 4, 15 has 5, 6, 7, 8 valence. Okay, so let me show you one more trick of the periodic table. This is really important. It's a great trick, and it's going to be very useful for the rest of the year. You can tell the charges of the representative elements just by their group number. So let's take a look at this. All the elements in group 1, since they have 1 valence electron, which we just said a second ago, metals give their electrons to nonmetals. So now that we know all the metals are over here, all on the left side of the periodic table, all these guys are going to give away electrons. So if they have 1 outer electron, they're going to give the 1 away. So they'll end up with a positive 1 charged ion. Everything in group 2 has 2 valence electrons. They're going to give both of those away and become +2 ions. Okay, transition metals, they don't play this game, so I'm just going to cross these out right here. Just forget about those. We can't tell their charges just by looking at their group numbers, okay? Just forget them. Let's jump over here to the rest of the representative elements. That's why knowing representative elements is important. Here we said these guys have 3 valence electrons. They're metals. They're going to give all 3 away and end up with positive 3 charged particles. Group 14, since they have 4 outer electrons, they really don't do ionic bonding. So we're just going to put a little X here. They don't do this, so forget about them. We'll talk about those in the future. Let's get over here now to group 15. We said these have 5 valence electrons, but now we're in the nonmetal section. All these guys in the upper right corner are nonmetals. If they have 5 valence electrons, how many more do they need to get to 8? Remember, the number 8 is the magic number in chemistry, and it refers to the octet rule. All elements try to have 8 valence electrons. The nonmetals do it by gaining electrons. So if they already have 5, they need 3 more. So if they have 3 extra electrons, they end up having a charge of -3 because the protons stay the same. So they're gaining electrons, they're gaining 3, they're going to have an overall charge of 3. Let's look at this one. If we have 6 valence electrons, how many more do they need to get to 8? 2. So when they pick up 2, they're going to have a charge of -2. And how about elements in group 17? They have 7 valence electrons. They need 1 to get to 8. So these will carry a charge of -1. 18 already has 8 valence electrons. So that's why they're inert. They don't gain electrons. They don't lose electrons. They don't do anything. They don't react. Great. See you next time.